Good morning, everyone. This subject is about discrete mathematics, and in discrete mathematics, the very first topic I chose here is propositions. Propositions. So, before going into what is proposition and its definition and its values and all, let us see the difference between a sentence and a statement. Sentence and statement. Sentence may be anything as sentence we can say. For example, suppose if Ram likes apple. Wow, it's beautiful. Just close the door. So you can see all these sentences, and from this we can classify whether it is a statement or not. What is statement? Statement means it must have some value. It must have some truth value. Whether we can say true or false for the statement. So that true or false reply or true or false value is nothing but a value to the particular statement. So if we define this as a variable, then true and false are the values of the variable. So Ram likes apple. So here we can say either it is true or false. It may be true or false. So it is a statement. It is a statement. And it's beautiful. Wow, it is beautiful. It is according to him or her, it is beautiful. We cannot generalize it whether it is beautiful or not. It is simply an exclamatory statement. So we cannot give any true or false value for this statement. So it is simply a sentence, not a statement. Here also just close the door. It is a command and we can obey or not. That is different. But here we cannot say whether the statement is true or false. The sentence is true or false. So these two are not statements. So it is in general, it is not about proposition. In general, we classify sentences and statements like this. And suppose if you take proposition as statements, right? So it is just like a mathematical term of statement. Proposition is just like a mathematical term of statement. So proposition is nothing but a variable we can say. So suppose if P is the proposition, we start with P, the name of the variable P, and if P is the proposition, then it has two values. So what are the values? True and false. So if P is the variable, then it has two values, true or false. Then according to the true values, these two true or false values are called truth values. Whether the proposition has this value or this value. And suppose if I take some examples for this, suppose if the same statement I'll take. Ram goes to temple. Ram goes to temple, or Ram never goes to temple. You can see the difference here. It is completely contradictory, but still both are propositions because we can say whether the statement is true or not. So here also we can say. So these two are statements. And suppose if I take a statement like this, I never visit Delhi. And another statement I take, I will visit Delhi. And one more statement, I may visit Delhi. As I said earlier, I never visit Delhi. We can say whether it is true or false. I will visit Delhi. Here also we can say true or false. So here in I may visit Delhi, you cannot say whether it is true or false because the sentence itself has some ambiguities. May means may or may not. So both you can say it is true or false. Both will be correct for this sentence. Okay, so this you cannot fix any truth value for this, so it is not a proposition. And suppose if you start with propositions, the notations, you can take the propositions as notations, then propositions as variables, then its notations usually take the variables p, q, r, etc. Just like x, y, z, here for propositions we start with p, q, r. And when we define a proposition, we should always take a positive statement. For example, suppose if I want to take I never visit Delhi, I can fix first p as I visit Delhi. And then I can take the contradictory of the statement p. So for this we need, so once we find the basic definitions of propositions and its values, we can go for the algebra of propositions. Suppose if two propositions, if you combine together, or if you take the contradictory of the given proposition, or you can go for either or type, you may have some algebra of propositions. So just like in set theory we have union, intersection, complement and all, ring sum and all. So here also we have the same operations, but the operations are with different notation, with different name. But you can compare union, intersection operations with these operations in propositions too. Before that we just check what is p. So p has two values I told already, which is true or false. That you can write it as 1, true as 1, false as 0, because in some books it may be referring 1 or 0. For our convenience only, either you can take true or false or 1 or 0. So when you write p, then its truth value are written like a column matrix 0, 1. So I am taking here all zeros and ones instead of true or false. So always you mean 0 as false, 1 as true. So now you can go for the propositions, algebra of propositions. That means operations on propositions. The first operation I define here is negation. Negation. So what is negation? Negation is the complementary statement of the given one. That is, when it is true, you have to write a statement which is false. So here suppose if I take p as I eat, and what is its negation? Negation of p is I do not eat. Okay, so this is what the negation. The notation is, if it is p is I eat, negation of p you can take it as a tilde symbol followed by p, or this symbol like the number 7, but it is not a slanting line, it is a simple vertical line p. There is a difference between 7 and this notation. Either you can use this symbol or this symbol. So whenever you want to fix it as I don't want, or I don't go to ground. Suppose if you want to write this as a symbol, as notation, then you fix first p as I go to ground. P as I go to ground, and negation P as I do not go to ground. In this way, you define the proposition and its negation. Suppose if you want to negate anything, then you put this symbol, negation, with that. So I'll go to other operations which combines the propositions, and negation you can take for the combination also. So this is the first algebra and first operation on propositions. Now I take conjunction. Conjunction. What is conjunction? You can take this as intersection in our set theory concepts. Intersection. What is intersection? Suppose if A and B are two sets, then intersection of A and B is another set which contains the elements which are in both A and B, which must be in both A and B. Then it is intersection. So here we can say P and Q are two propositions. P and Q are two propositions. We are combining this P and Q as with P conjunction Q. P conjunction Q, okay, denoted by P, just like intersection. So what is the symbol for intersection? You have this. Here we have a sharp end, that's all. Same notation with the sharp end. So P and Q, or you can write this as P, you can say this as P and Q. How do you find the truth value for P and Q? That is, it is another proposition. Another proposition. So here also we have truth value, because if it is a proposition, it must have a truth value. So P and Q has only two truth values, which is 0 or 1. So how do you find? Because P has 0 and 1, Q has 0 and 1. When we combine P and Q, how we can define truth values? So I'll start with P and Q. So what are the truth values for P? It is 1, 0. Suppose if P is 1, Q may be 1. If P is 0, Q again 1. If P is, suppose for 0, if I take for Q, if it is 0, we have 1, 0. You can understand here there are 4 combinations, because we have 2 variables, each has 2 values. So it is not just like 2 power 2. Suppose if you take 3 variables, each has 2 values, then it is 2 power 3 values, 2 power 3 combinations you have. So P and Q, suppose if I take, there are only 4 possible combinations, and P and Q takes truth value 1 when both P and Q are 1. Both true, then it is true, otherwise false. Otherwise false. Suppose if I take another operation as disjunction, I'll take the same truth table and then I'll take it here itself. Disjunction we can mean as union in set theory. In set theory, union is denoted by like U symbol, and here also we have P and Q are 2 propositions, and P disjunction with Q denoted by P disjunction Q or PRQ. PRQ, which is defined as the same thing. I'll take here PQ and the truth value for PRQ, because PRQ is another proposition, it has truth values. Here we can see R. What is the R operation in set theory? It is nothing but if either one of the set has the element, then it will be involved in the union of the set. So the elements which are belonging to either A or B, okay, even or both. So P union Q is, it's a flexible statement. So if either one is 1, it is 1. If one of the term is 1, then it is 1. Or if both are 1, it is 1. But if both are false, then only it will take 0. So here we have all true except when both are false. This is another operation. Negation, conjunction and disjunction. Now you can go for, okay, I'll tell some examples for this conjunction and disjunction. Okay, so here conjunction. Okay, suppose if I write Ram and Sam go to college. Always you can say that P as Ram and Sam go to college. But if you have in the sentence any conjunction word, then you have to separate into two statements, that is two propositions. Because usually people will do P, Ram and Sam go to school, that's all. It is not like, because Ram goes to school is one statement, Sam goes to school is another statement. And is the conjunction. And is the conjunction. So we have to define like this. Ram goes to school. And Q, Sam goes to school. Then Ram and Sam goes to school. Ram and Sam go to school. Sorry, I think I am taking it as college. Okay. Go to school implies, when you write it in symbols, it is P and Q. P and Q. Suppose if I write Ram goes to school but Sam do not or does not. Ram goes to school but Sam does not. So here we can take P, Ram goes to school, Q, Sam goes to school, and here you can write Ram goes to school, that is P, but this but is the conjunction. But is not related with the two statements. This is a separate statement, this is a statement. So P and, but is always conjunction. Sam does not go to school. Does not go to school means a Q, so negation Q.